Hello everyone, this is Brendan, and this is going to be a short video about conversions in chemistry. This video also applies to physics and many different math classes, basically anything that involves the metric system. So what I have presented over here to the left is a conversion table for values within the metric system. So you can see I have the prefix followed by the symbol followed by the conversion factor. So the one symbol that might look a little weird is the one down here for micro, which is given by mu. That's the Greek letter mu. Let's talk about how we can use these conversions in a problem that you will likely encounter in the first few weeks of your chemistry class. So the way this works, I'll go ahead and just present you with a problem. Problem you might see at the very beginning might ask you to do a simple conversion between centimeters and meters. So let's convert 25 centimeters to meters. Well, what you want to do in all conversions in chemistry is think about the units. How do you want these units to cancel out with each other? So you're always given a number with some kind of unit attached to it. That's always going to be the first value you write down in your conversion. So my first number and value leads me to 25 centimeters. Next thing you want to do, a lot of teachers might have you set this up a little differently. The way most of the teachers of my students have them set it up is by setting up a little box-like structure here. And all this is a multiplicative fraction where you're multiplying by the numerator and then the denominator. When you approach this, the first thing you want to do is make sure your units are going to cancel out. I currently have centimeters in the top here. You can put this over 1. Some teachers will recommend that. And I want centimeters to cancel. Well, if you have something in the numerator and you have that same thing in the denominator, they just cancel out. It's like x divided by x or 5 divided by 5. They just disappear and become 1. So I want centimeters in the bottom, and I'm trying to convert 2 meters, so I'm going to put that in the top. Well, the way these conversion factors work and the way that I'm presenting you with this material is this conversion factor will always go with the unit that doesn't have the prefix, or what I call the base unit. Meters is the base unit here. Centimeters is not, because centimeters has the prefix. So the 10 to the negative 2 will go with meters because that does not have the prefix. And a 1 will just go with the term that has the prefix. You could then put this in your calculator, find out what answer you get. With fractions, you multiply straight across the top and straight across the bottom. 25 times 10 to the negative 2. Something to remember about scientific notation is when you have negative exponents, you move the decimal place that number of places to the left. So since it's negative 2, I move my decimal place 2 spaces to the left, and I come up with an answer of 0.25 meters. Again, we can see that the centimeters have disappeared. Let's try another problem that's pretty similar. Next problem we're going to try is we're going to convert from, let's do 45 liters to milliliters. So we're now going the opposite way. Before we went from the one with the prefix to the one without. Now we're going without to with. So again, same process applies. You're given some number and some unit. You always start your conversion with those. Go ahead and put it over 1. Set up this little box right here. Think about what unit you're trying to cancel. What unit are you trying to make disappear in this problem? The answer is liters. So the way that I'm going to make liters disappear is by putting an L down here, because now they're simply just going to cancel out when I multiply them. And I'm trying to get 2 milliliters, so I'm going to put ml in the top. I'm going to look to my conversion factors. Eventually you want to memorize these. For now it's okay if you haven't, but by the time you have a quiz or a test in your class, definitely going to want to have these down. Your teacher might have you memorize more than these or less than these, so pay attention in your class, see what's required of you. But anyway, I'm going to look over here, and I'm seeing the prefix for milli is 10 to the negative third. Remember, that conversion factor always goes with the base unit, the one without the prefix. So what I'm going to do is I'm going to put this 10 to the negative 3 with liters. Notice how this is exactly the same as before when I put the 10 to the negative 2 with the meters. It's not whether it's on the top or the bottom where it goes, rather it's with the base unit, what lacks the prefix. And then a 1 is just going to go with milliliters. So you go ahead and you see liters cross out, you multiply straight across. So this becomes 45 divided by 10 to the negative third. In order to pull an exponent to make it positive, you can just bring it to the top. So this is like 45 times 10 to the third, which tells you to move your decimal place 3 places to the right. So it would be 45 point, and then you move it over 1, 2, 3. You fill these spaces in with zeros, and you find that 45 liters would equal 45,000 milliliters. Let's just do one more example. These are pretty simple. If you feel confident, you feel like you get it, go ahead to the next video. Otherwise, just join me for one more example here. Alright, so the next example I'm going to do is I'm going to convert from 2.78 centiliters to liters. So again, same process, same everything as I go through this. I'm going to start with the number and the unit, which I'm given. I'm going to set up my little box here. I'm going to put centiliters within the denominator because I'm trying to cancel it out. I'm always looking for, what am I canceling? How am I going to make this disappear? And I'm going to put liters in the top. And I'm going to look back to my conversion factor for centi, which is 10 to the negative 2. Again, it goes with the base unit, not the one with the prefix. So 10 to the negative 2 liters per 1 centiliter. Again, I can see how my centiliters cancel out. Multiplying and dividing by the same thing is going to disappear. So I end up with 2.78 times 10 to the negative second liters. When I have a negative exponent, it tells me to move it 2 places to the left. So this becomes 0.0278 liters. And we can see how 2.78 centiliters is 0.0278 liters. Join me in the next video. I'm going to do multi-step conversions. And in the video after that, we're going to do things that are a little bit more complicated than this as well.